Hello one and all, and welcome to the Math Magic Show. In this one we're going to find the value of this integral here, but using only purely geometric reasoning. So, the integral is from -3 in the lower limit up to +3 in the upper limit, and the expression is the positive square root of 9 minus x squared. Let's not forget that little x. To do this geometrically, let's proceed as follows. I need to first realize that when we say the integrand is the square root of 9 minus x squared, it's as if I could say y equals that quantity, 9 minus x squared. Why do I want to see it that way? Because from there I can get information out of it that tells me it's actually a circle. This is what I mean. Take a look. So y equals the square root of 9 minus x squared. That means that when I square both sides, I will have y squared equals the square root of 9 minus x squared. But now on the right side, I have a square of being applied to the root. In other words, the effect will be that that 2 and the root symbol will cancel off. So I've squared both sides here. On the right side, basically I'm going to get the following, that y squared on the left side equals 9 minus x squared. And this is already beginning to look more like the equation of a circle. Now I just add x squared to both sides. So I'll have y squared plus x squared equals 9. Now this is exactly the equation of a circle. You have y squared and x squared, you have plus between them. On the right side, you just have to show the radius. So the radius will look like this. It's going to be y squared plus x squared. And here it doesn't make any difference whether you put x squared plus y squared because you're adding squared quantities, so it makes no difference. But on the right side, I'm going to rewrite the 9 as 3 squared. Now, why would I do that? Because that 3 that you see in the base down in this position tells me that I have a circle of radius 3. Let's actually walk over to the graph now. In the graph, this is going to look like this. I'm going to draw my y-axis, my x-axis. I hope you can see those clearly. They're green. Then I'm going to draw basically a mark at x equals +3, one at x equals -3. Why am I doing that? Because that's the radius of the circle. So if I measure from the center, which is 0, 0, to mark the circle, you would basically begin from the center and go 3 to the right, 3 to the left. And then I'm going to also measure 3 up along the y-axis at that mark. And then you kind of fill in the rest of the detail with an arc that is semicircular to the best of your ability. You get the idea. So that basically is the top of a circle. How do I know it's the top of the circle and not the whole circle? Just to emphasize this point, remember that over here, an integral, it says no symbol is written. In other words, it implies that it's a positive square root of 9 minus x squared. That's the top of the circle. If you had a negative in front of it, then it would be the bottom of the circle, you see? Now, just to emphasize this point, what this integral represents is the following. You've got your limits, -3 to +3, and then you might want to just shade the area. So it's the area of half a circle, that's all it is. So let's actually work that out. So the area will be equal to the following. You got to use the basic area formula for a circle. But the only difference is in this case, because it's only the top of the circle, first you have to multiply by 1/2 to take the half of it. Then you put your pi, and then you put the radius squared. So here in the circle itself, you can imagine drawing a little line from the center to any point on the circle. And maybe emphasize the fact that it's 3 units. So I did that here by writing 3. And then that value will be used in the formula below. So it's going to look like 3 squared in this position. And then you just work that out. So it's going to be 1/2 pi times 9. And then it's going to be, just move the 9 over the 2. So it's going to give you 9/2 of pi as the value of the integral. You might also consider writing this simply as 4.5 pi or something along those lines, or you might be asked to work it out in a decimal approximation, so just punch it into a calculator. Okay, but that is it for me. Thank you so much for watching. I hope it's been helpful, insightful. Please leave a like and subscribe, and I will see you in another video.